The Rover V8 engine is a compact V8 internal combustion engine with aluminium cylinder heads and cylinder block, originally designed by General Motors and later redesigned and produced by Rover in the United Kingdom. It has been used in a wide range of vehicles from Rover and other manufacturers since its British debut in 1967. History: the Rover V8 began life as the Buick 215, an all-aluminium engine introduced in 1960 for the 1961 U.S. model year. The compact, all-alloy, engine was light, at just 144 kilograms, and capable of high power outputs. The most powerful Buick version of this engine rated 149 kilowatts, and the very similar Oldsmobile Jetfire turbocharged version made 215 horsepower. Based on sales volume and press reports, the engine was a success. Buick produced 376,799 cars with this engine in just 3 years. A comparable number of Oldsmobile 215 engines were produced. In addition, some Pontiac models were fitted with a Buick 215, leading to the nickname BOP 215 for the engine. The aluminium engine was relatively expensive to produce, however, and it suffered problems with oil and coolant sealing, as well as with radiator clogging from use of antifreeze incompatible with aluminium. As a result, GM ceased production of the all-aluminium engine after 1963, although Buick retained a similar 5000cc/300 SID engine, as well as a V6 derivative which proved to have a very long and successful life. In January 1964, Rover gave American operations head J. Bruce McWilliams permission to investigate the possible purchase of an American V8 engine for Rover cars. History relates that McWilliams first saw the Buick V8 at the works of Mercury Marine, where he was discussing the sale of Rover gas turbines and diesel engines to the company. However, it is likely that McWilliams was aware of the Buick engine before this. In any case, McWilliams realized that the lightweight Buick V8 would be ideal for smaller British cars. McWilliams and William Martin Hurst began an aggressive campaign to convince GM to sell the tooling, which they finally agreed to do in January 1965. Retiring Buick engineer Joe Chalet moved to the UK to act as a consultant. The Rover V8 has long been a relatively common engine for kit car use in Britain, much as the Chevrolet small block V8 is for American hot rod builders. Even in the US there is a strong contingent of builders who select the Buick or Rover aluminium V8 engine for use in small sporty cars like the MGB and the Chevy Vega. The 1964 Buick Iron Block 4920cc engine had aluminium cylinder heads and a longer stroke crankshaft, which with modification can be used with the Buick 215 or Rover engine blocks to produce a high output, very lightweight V8 with displacement of up to about 300 cubic inches. The 300 crank in the 215 block yields 4,260 cc's. Traco and the USA were prominent builders of such engines. The British-made engines were run on two SU carburetors, initially HS6 then HIF6 and HIF44 variants, then two Stromberg CD175 carburetors, Bosch L-Jetronic, then Hitachi Hotwire, then the GEM system and finally Bosch Motronics for 2 years. The engine is still cast now, in an improved version, by Cosast in Birmingham, UK. As well as appearing in Rover cars, the engine was sold by Rover to small car builders, and has appeared in a wide variety of vehicles. Rover V8s feature in some models from Morgan Plus 8, TVR, Triumph Trail 8, Land Rover and MGB V8, among many others. The demise of the MG Rover Group in 2005 led to a halt in production of the famed name Rover V8 after 40 years. The last Rover to have a real Rover V8 was the Rover SD1, which was replaced by the Rover 827, with a 2.7-litre Honda V6 unit. The Rover V8 remained with Land Rover when it was sold to Ford by BMW. Although Land Rover has switched to the Jaguar AJ V8 engine for new applications, they wanted production of the engine to continue, and they arranged for production to restart in Western-super-Mare under MCT, an engineering and manufacturing company. MCT will continue limited production of the engine for the foreseeable future, supplying engines for aftermarket and replacement use. The Rover V8 based on the Buick design was not the first V8 engine produced by Rover. When the Rover company was having engineering differences of opinion regarding the development of the Whittle turbine engine, the Wilks brothers did a deal with Rolls-Royce to swap technologies. The turbine engine project at Barnoldswick went to Rolls-Royce and Rover company took over the V12 Meteor engine production used in the Centurion tank. From this a V8 variant was developed. The Rover Meteorite, also known as Rolls-Royce Meteorite, was a V8 petrol engine of 18.01 L capacity. In essence it was two-thirds of a V12 Meteor, and it shared the Meteor's 60-degree bank angle. Meteorites were built for vehicles, for marine use and as stationary power units. It powered the Thornycroft Antar Almighty Antar tank transporter Euro, and as such was used to transport Meteor engine tanks Euro, and also heavy transport on the Snowy Mountains hydroelectric scheme in Australia. Racing, as the aluminium block made this engine one of the lightest stock V8s built, it was an obvious choice for use in racing. Mickey Thompson entered a car powered by this engine in the 1962 Indianapolis 500. From 1946 to 1962 there had not been a single stock block car entered in this famous race. In 1962 the Buick 215 was the only non-Offenhauser-powered entry in the field of 33 cars. Rookie driver Dan Gurney qualified 8th and raced well for 92 laps before retiring with transmission problems. The Rover version of this engine was extensively developed and used for rallying, especially in Triumph Trail 8 sports cars. The Australian Refco 5.8 F1 engine being based on Buick 215 block is technically a common misconception, as the Rover Buick V8 had only 5-cylinder head studs around each cylinder unit and that cannot accommodate the 6-stud Refco RB620 heads. The Refco V8 was based on Oldsmobile 215 block of the same era, which was very similar in appearance, size and material, but used 6-cylinder head studs per cylinder. The subtle difference in block design head clamping originated in Oldsmobile's intention to produce the higher power, turbocharged Jet 5 version of the small light V8, however, the public press tended not to be aware of the internal difference. Hoatstocks use Rover V8 in their stock cars. 3.5 L, the initial Rover version of the engine had a displacement of 3,528 cc's. The bore was 88.9 mm and the stroke was 71.0 mm. It used a sandcast block with pressed-in iron cylinder liners, and a new intake manifold with two SUHS6 carburetors. The Rover engine was heavier but stronger than the Buick engine, with a dry weight of about 170 kilograms. It was first offered in the 1967 Rover P5B saloon, initially making 160 picoseconds at 5,200 rpms and 210 lb-ft of torque at 2,600 rpms on 10.51 compression. With the introduction of the Rover SD1 in 1975, the engine was improved with the rope oil seals for the crankshaft ends replaced with lip seals, spark plug dimensions changed and the compression ratio lowered to 9.351. Applications: 1967 Euro 1973 Rover P5B, 1968 Euro 1976 Rover P6B, 1968 Euro 1990 Morgan Plus 8, 1970 Euro 1989 Land Rover Range Rover, 1973 Euro 1976 MGB GT58, 1972 Euro 1978 Land Rover 101 Ford Control Military Vehicle, 1979 Euro 1981/2 Triumph Trail 8, 1978 Euro 1985 Land Rover Series 3. Stage 1, 1976 Euro 1987 Rover SD1, 1980 Euro 1990 TVR 350i, 1989 Euro 2004 Land Rover Discovery, 1983 Euro 1994 Land Rover 90 Defender, 1986 Euro 1991 Sisu NA140BT all-terrain transport vehicle. Project Iceberg. In the late 1970s, British Leyland became aware of the increasing importance of diesel-engined cars to the British, European and North American markets in the wake of the 1979 energy crisis. It was decided that a new series of diesel engines powerful, refined and economical enough for use in BL cars was needed. However, with development funding tight, it was necessary to use existing BL petrol engines as a base. This included a diesel version of the 3.5-litre V8, the development project for which was codenamed Iceberg. BL collaborated with Perkins Engines of Peterborough to develop the engine. Both naturally aspirated and turbocharged versions were produced, both using a Stanidine rotary mechanical fuel injection system. Power outputs of around 100 and 150 horsepower were achieved. The Iceberg engine was slated for fitment in the Range Rover, Rover SD1 and the Jaguar XJ, but the project encountered problems with failure of the alloy cylinder heads and internal cooling. They were limited by the need to use the same basic block casting as the petrol engine to allow the Iceberg engine to be produced on the same production line to reduce costs. Whilst these problems could have been overcome, the project ran into financial and logistical problems caused by the reorganization of BL and specifically the splitting of Land Rover and Rover into separate divisions. Land Rover took over production of the V8 engine in 1982, moving it from the main BL engine plant at Cox Green into a new, much lower capacity production line in the Solihull Works, where it was built alongside the other Land Rover engines. This meant that there was no spare capacity to build diesel versions of the engine. Coupled to this, it was clear that the market for large diesel-engined cars in North America had not developed as expected. BL finally pulled out of the project in 1983. Perkins initially decided to pursue the project alone, and even produced advertising brochures for the engine as an industrial power unit, but BL withdrew all technical support and Project Iceberg was wrapped up in late 1983. BL's other collaboration with Perkins produced the highly successful Prima unit. BL bought in 2.5-litre four-cylinder turbo diesel units from VM Motori to use in the SD1 and Range Rover 3.9/4.0. Land Rover used a 3,946 cc's version of the Rover V8 through the 1990s. Bore was increased to 94.0 mm and stroke remained the same at 71.0 mm. The engine was revised in 1995 with a new intake and exhaust system, extra block ribbing, revised pistons, and larger cross-bolted main bearings. The 1995 4.0 produced 190 horsepower and 236 lb-ft. Production of the 4.0 ended in 2003. The final version of the engine, used in the 2003 Land Rover Discovery, produced 188 horsepower at 4,750 rpms and 250 lb-ft at 2,600 rpms. Applications: 1990 Euro 2004 Morgan Plus 8, 1991 Euro 1995 Ginetta G33, 1992 Euro 1996 mg of V8, 1986 Euro 1993 TVRS Series, 1989 Euro 1995 Land Rover Range Rover, 1991 Euro 2000 TVR Griffith, 1992 Euro 2001 TVR Chimera, 1995 Euro 1999 Land Rover Range Rover in SE trim, 1994 Euro 1998 Land Rover Defender, 1986 Euro 1991 Sisu NA140BT all-terrain transport vehicle, 1998 Land Rover Defender 50th Anniversary Limited Edition, 1996 to 2002 Land Rover Discovery Series I, 2. In the early 1980s TVR approached Andy Rouse with a view to using his race-developed 3.9L variant of the V8 in their Rover-powered 350i wedge. Rouse had successfully campaigned a Rover SD1 with a modified V8 on the track. For a number of reasons Rouse's version was not used, but the concept was passed to alternative engineering firms which resulted in a rare variant of the 3.9. This unit has 93.5 mm cylinder bores and thus has a capacity of 3,905 cc's. Flat-topped pistons and high-lift camshaft gave a compression ratio of 10.5 to 1. TVR claimed 275 bhp as the output, and whilst this is generally disregarded by aficionados, a healthy 3,905 cc's engine will produce in excess of 240 bhp. Once a reproducible specification had been determined, the bulk of engine production was undertaken by North Coventry Kawasaki, which company was subsequently purchased by TVR to become their in-house engine division known as TVR Power. About 100 cars were built with the 3,905 cc's engine. TVR's later 400 offering being based on the then-current Range Rover 4L of 3,946 cc's. Applications: 1986 Euro 1989 TVR 390 SE. 4.2 Land Rover extended the 3,946 cc's engine for the top LSE specification of the classic Range Rover. The 4.2L engine had a displacement of 4,275 cc's, and used the crankshaft castings from the failed Iceberg diesel engine project. Bore remained the same at 94.0 mm, while stroke increased to 77.0 mm. Applications: 1992 Euro 1995 Land Rover Range Rover. 4.3 For the Griffith and Chimera, TVR Power, a Coventry-based subsidiary of sports car maker TVR, built a Rover V8 version with a 4,280 cc's displacement using the 77 mm stroke crankshaft as per the Land Rover 4.2 engine, but with a 94 mm bore size. The so-called pre-cat versions of the Griffith predominantly used this engine, although a 4.0-litre version was also available. The Chimera was introduced with choice of 4.0 and 4.3-litre engines. A small number of big valve versions, sporting modified cylinder heads with 43 mm intake and 37 mm exhaust valves and a more radical camshaft profile, found their way to early Griffiths and Chimeras. Applications: 1992 Euro 1993 TVR Griffith, 1993 Euro 1994 TVR Chimera. 4.4 Leyland of Australia produced a 4,416 cc's version of the aluminium V8 for their Australia-only 1973 Leyland P76. The bore was 88.9 mm and the stroke was 88.9 mm, making it a square engine. The block deck height was extended and longer cone rods were fitted 158.75 mm between centers. This rare engine produced 200 horsepower and 280 FTA Euro cent lbf and, although export versions were planned, the closure by British Leyland of their Australian operations in 1975 precluded the widespread application of this engine. British Leyland did import one complete P76 engine for assessment, but it was never fitted to a vehicle and was sold off on the demise of the company. Applications: 1973 Euro 1975 Leyland P76, Leyland Terrier truck. 4.5, not to be confused with the later 4.6-litre engine which TVR badged as a 4.5 for the Chimera. There also existed a version with an 80 mm crank and 94 mm bore giving 4,444 cc's capacity, which was used by TVR in the low-volume Special 450 SEAC, the race version thereof and the subsequent Tuscan Challenge Racers. A tiny number of Griffith and Chimera road cars were built with a version of this engine, known as the 450 BV. 4.6 In 1996, Land Rover enlarged the Rover V8 to 4,552 cc's. The bore remained the same size as the previous 4.0 at 94.0 mm, but the engine was stroked by 10.9 mm giving 82 mm in total. Output was 225 horsepower and 280 FTA Euro cent lbf. Production of the 4.6 ended at Solihull, UK, in 2002. The final version, used in the Range Rover, produced 222 horsepower at 4,750 rpms and 300 FTA Euro cent lbf at 2,600 rpms. The last mass-produced application of the Rover V8 was the Land Rover Discovery, up until the vehicle was redesigned in 2005. It is still used by some hand-built sports cars built by some independent manufacturers. Applications: 1995 a Euro 2002 Land Rover Range Rover in the HSE trim, 2003 a Euro 2004 Land Rover Discovery, 1996 a Euro 2002 TVR Chimera. 5.0, a 5-litre 4,997 cc variant of the Rover V8 was used in two models by British sports car manufacturer TVR. The bore was 94.0 mm and the stroke was 90.0 mm. These models, the Griffith and Chimera, used the 5-litre unit in their top-end specifications. The factory quotes up to 340 bhp and 350 lb-ft of torque. Applications: 1990 to 1995 Litchfield Land Rovers, 1992 a Euro 2001 TVR Chimera, 1992 a Euro 2000 TVR Griffith, 2002 a Euro 2006 Bowler Wildcat. This used a hybrid 5.0-litre V8 with Land Rover cylinder heads and a TVR block and piston assembly. Moreover, in the mid-1980s, hot rodders discovered the 215 could be stretched to as much as 5L, using the Buick 300 crankshaft, new cylinder sleeves, and an assortment of non-Buick parts. It could also be fitted with high-compression cylinder heads from the Morgan Plus 8. Using the 5-litre Rover block and crankshaft, a maximum displacement of 5,208 cc is possible and used primarily in racing applications. References: Engines Rover V8. Online. Retrieved June 18, 2013. Heath, Steve. The TVR Griffith and Chimera. Steve Heath Publications. ISBN 0-9530335-5-4. External links: the Rover V8 American Connection, Rover V8 World, V8 Church, Rover V8 Information and Community, V8 Church, the Rover V8, the unofficial Austin Rover web resource, Jetfire History, Olds FAQ, the British V8 Newsletter, TVR Griffith Owners Register, History, Mods and Maintenance, V8 ECU/Engine Upgrades.